Hey guys, welcome back to AlgoYogi. We are doing binary search series, and our next problem in the list is capacity to ship packages within D days. So let's visit the problem on LeetCode. So a conveyor belt has packages that must be shipped from one port to another within days. Okay, so days. They should have said it D days, but days. That's the name of the variable. And the ith package on the conveyor belt has a weight of basically the element value over there, weights I. Each day we load the ship with packages on the conveyor belt in the order that's given to us by weight. So basically this order. So if you start loading the ship with these packages, you start with 1 and then 2, 3, 4, 5 in the same order that's given to us. We may not load more weight than the maximum weight capacity of the ship. So this is something, this maximum weight capacity, that's some number that this ship has, and we cannot load more than that capacity in the ship, right? So now we need to return the least weight capacity of the ship that will result in all the packages on the conveyor belt being shipped within days. Okay, so days in this example, let's understand that over here, what we want to do is we want to ship all of these packages. This is the weight represented here of each package within this many days. So in this example, first example, in 5 days, we have to ship all of them, and we need to find out what should be the minimum capacity of the ship, so that we utilize all the days, 5 days, choose the minimum capacity to basically load that number of packages into ship. It's not the number of packages, it's like the total weight of the packages. That's what the capacity is about. So tell me, let's say if we have our if we have our ship over here, this is our ship, okay, this is our ship, and we need to load, and we need to find this minimum capacity, so that we are able to ship all of these packages and utilize all the days that are given to us. So let's say, how about we just basically choose what should be the range of our capacity, by the way. Shouldn't it be basically the minimum from here, and maximum from here? Should it be that? And it could be that. Why not? Because let's say if I just put minimum capacity is basically 1, then I could load this particular weight, and then I'm also able to load basically in this range. If I'm choosing this range, this is basically I'm trying to decide a range of this capacity that we can choose. But honestly, what I realize is, how about we just have some decent capacity range, so that we are able to even ship all of these together, even in one go, even in one day. I know we need to utilize all the days, but the range could be the sum of all of these. So what I'm trying to say is, how about our range is, what is the sum of all of these? So sum weights, and in this case, if you remember the formula, that would be 10 plus 1 by 2, so 11 into 10 is 110, divided by 2 is 55. That should be the sum of it, all of it here. So if that is our range, so that is our upper bound, by the way. This is our upper bound. 55 is our upper bound, and what should be our lower range is the maximum from here. So what is the maximum from here is 10. So basically, if I'm choosing 10, that means I can at least take one package, or I could take all the package if this is my range. Okay, so this is the range of the capacity that I should be choosing. If you want to, you can choose one as well, but this is more I would say sensible range that we should be aiming for. And that's because the minimum, if we have minimum 10 as capacity, then we are able to take the maximum package weight as well. If we can only take like just one package with us. So tell me, now we need to choose minimum capacity in this range. So maybe how about we just run a linear search on this. So what I'll do is I'll just have a for loop. So for C in range, basically range would be minimum is basically 10, or I could even choose 1 as well here, but honestly that wouldn't even go for all of these. So I would rather have 10 so that it just at least for that range we are able to process all the packages, right, to find out the number of days it will take us. So what I'll do is I'll have my range 10 to basically 55. All right, I'm gonna do 55 plus 1 so that it just includes 55, because it doesn't if in the for loop. So what's really gonna happen here is I come over here and then I start, basically I'm gonna start a for loop in weight. So for W in weights, I want to find out how many weight I can basically ship if my minimum range is basically the C, for C. So right now it will start at 10, so I'll be able to take 1, 2, 3, and then I will be able to take 4 as well. So 3, 2 is 5, and 6 and 4 is 10. So I'm able to take all of these together, and that will be 1 day. Okay, so I'm just gonna remove this here and I will start counting my days, right? I will have days. So this will be day 1. So 1 day gone here, and then I know whenever I'm collecting them here, so I'll be collecting it from using this for loop, and once it becomes basically greater than this capacity, then I just come out of this loop and start processing basically next capacity. But I'll know because I'm going from lower to upper bound. Then if I am able to process, if I find a capacity, let's say in this case I was able to basically process this day 1, then I'll start over here. So 5 and 6, 5 has to go another day because 5 plus 6 are greater than 10, so I can't process both of them together, but I'll process 5. So plus 1, then 6, plus 1, then 7, plus 1, and then 8 another day, plus 1, and this is already 5 days, and I still have 3 more packages that I need to ship. So that means what? I cannot process 10, could not be my minimum capacity that I can choose for processing, basically choosing that as a capacity to ship all my packages within 5 days. Okay, so what do? I increment my capacity here. So I will increment, basically this will keep incrementing. We have the for loop, so it will now process 11, and you'll realize 11 will also be not able to do that within 5 days. So if you choose 15, when it comes to 15, and they have shown it in the example, so I'll process for 15, I'll process these 5 in the first day, these two 7 plus 6 13 in the second day, plus 1, these over here, this over here, second day, and third would be this, fourth would be this, and fifth would be this. So third day, fourth day, fifth day, and this is first and second day. So first and second day. Now we are able to process. If we choose our minimum capacity as 15, then we are able to process all of these packages in this particular group. So first 5, second 2, and then third, fourth, fifth, all of them 5 days done. So this is my brute force solution. So this is where we understand the problem. What we are really trying to do, we're trying to find this minimum capacity that we choose so that we are able to ship all the weights within days, within 5 days in this case, and within those days we are able to ship all of the packages and still have that minimum capacity for our ship. For maximum capacity, we could choose like the whatever the sum of all the weights would be. That if we choose that big of a ship, it will cost us a lot of money. So we are trying to minimize, like we're trying to choose the smallest ship with the smallest capacity so that we are able to ship all of them within this many days. If the day was just one, we would have to it would have to be summing them all of them together and then basically sending them on day one. So that will be our brute force solution, but that will not pass all the cases. That's why we need to apply this better solution. And this one, you can easily have this for loop, have another for loop checking for all of them, and then you find out the capacity and then return that capacity. Once basically you're the days that you will be calculating over here, by basically summing them up together. If they are basically less than or equal to the days given to us, then that means we are able to successfully ship them and return that capacity. Now, why this problem is in binary search category? This is why, because we know the range, and we need to basically choose this capacity, minimum capacity, by searching in binary search fashion. So it's just like finding a capacity but using binary search. So we know our range would be 10, 11, 12 to basically 55. That's the sum of these values over here. Okay, then if this is my range, rather than trying to find in a linear fashion, I will try to use binary search. Okay, I will try to use binary search. So in binary search, what do? You have this left pointer and you have this right pointer. Then you try to find out the mid. In this case, it would be basically 65 divided by 2 would be 2.5. That will be 32. So let's choose 32 as my mid, to basically choose as the minimum capacity so that we are able to ship. And you will realize that yes, we will be able to do that, because for 32 maybe we will be able to basically ship all of these together or something, and then these two together. So 2 days, right, which is way less than our 5 days. But you know what, that's not our target. This will work as our answer, but what we are trying to do is we want to minimize this target that we are choosing. So what we'll do, if this passes, we will have our result variable. We will assign this 32 over here and we'll basically update it to minimum of res or 32 or whatever value we find out as mid, and we will only process this mid if using that for loop we are able to process them. If this is our capacity, so we keep adding them up wherever it becomes greater than 32, we increment our days. So you know what, it would be better if we I don't want to make this video too long, but it would be better if we understand it nicely by going through how we are actually deciding. So for one of them it will be nice. Okay, going over for one example. Okay, let's go again. It will be better to understand. So we have this range, okay, so this is my range, left pointer, right pointer. I have my result. Initially my result is basically maximum. I'm gonna have 55 so that it gives me at least I can process all of them in one day. Then I choose my mid is 32. Now if I can process 32 weight in one day, what does that mean? So how many days I need to calculate now within that. Okay, so while left is lesser than or equal to right, mid is basically left plus right divided by 2, and then now if this is in, like right now in this case 32 is my mid. So I want to find out num days when m is my capacity. So how will I do that? I will have a for loop for c in, I'll just say w in weights, and I will just sum them up in s plus equals to w, and whenever this becomes basically greater than, this is greater than or equals to basically my I would say my m mid basically, then I will increment my days. This is what I'm trying to increment. So I will basically num days I will increment by 1. Okay, and initially num days I'll assign this as 1 because I need at least 1 day to process that. Okay, and later I'll just keep adding it. So I'll, like when we write the code you'll understand, but now for theoretically what we're trying to do here. Okay, and we keep doing that, and we'll keep finding basically the capacity, and later if those days we just collect it together, if they are lesser than or equal to the days that are given to us as basically the condition, then we will have assigned this to my answer as result equals to minimum of result or minimum not minimum. Okay, all right. So and then if this is the case, we'll keep basically bringing my right pointer to mid minus 1, so that will be now 31. So now this is the range we should be looking for my next minimum capacity, and later you'll realize we'll 31 plus 10 is 41 divided by 2 will be 20, and then again you'll realize 20 is even little greater because 15 should be the answer that we just found out from the brute force solution. And this problem is a lot similar to that Koko monkey eating banana problem. So I guess you do that one first and you'll realize like how easy it would become for you to solve this problem. And this will be basically of time complexity if we write that solution. So time complexity would be basically you are doing binary search on basically log, if the capacity, let's say the range of capacity is basically from values from minimum values to the maximum values. So we could just say from 1 to the maximum k. So let's just choose that value as k, and then you are for each of this each of this capacity that you're choosing, you're basically again going through the entire weight, let's say that's of size n, to basically sum them basically grouping them together so that they are processed within days. You're calculating the number of days. If you choose c as capacity within that range, within k range from 1 to k, and then trying to find the number of days it will take you to process all the weights. So that's how you're doing it. So this is our time complexity, and space complexity is basically constant. Okay, so I guess this is the time to write down the solution. Okay, I'm gonna switch the view. Okay, looks pretty nice. Looks nice. So brute force solution, you can write it yourself. We're gonna write the binary search solution. So let's have left and right pointers pointing to basically, let's find the total first. So total would be sum all the weights. Okay, all the weights. So left would be basically, as we said, maximum from weights, and right would be total weight. So that right is the upper capacity limit, and this is I'm choosing so that I can process all the packages together in the ship and ship them away to the another port. So that's one of the solution, but that is like the maximum. Minimum is at least I'm able to ship the maximum package in 1 day. If I don't choose that we are not allowed to break the weights, right? We're not allowed to break the weights in different weights, and then you're not allowed to basically break the package. Package has to be in whole together, and I need, if I have to basically ship one package per day, it has to be the maximum package that I'm able to ship. That's why the range here is basically max, weights, and total. So now we're gonna have a while loop that is until left becomes greater than right. Let's find out the mid. Mid would be basically right plus left divided by 2. Now is when I want to start basically if I'm choosing this mid, so how many days it will take me if m is my basically capacity. If m is my capacity, so what I'll do is I will use a for loop to find the number of days. So I'll have num days initially as 1, because at least I will require 1 day, because I do have some packages, right, that I need to process. So if I have some weights, that means I need at least 1 day to process them all of them up. And I have these num days, and I'm going to have basically current weight, so that I know whenever this current weight becomes greater than m, then I know that this is done. I need another day to start shipping more weights, and that's where I will reassign this weight as 0. Okay, so current weight is 0 currently. So for w in weights, what I want to do is if my w, this current weight plus this w weight, and my that weight that I'm maintaining so far, current weight, this becomes greater than equals to is fine, but it becomes, if it becomes greater than this capacity that I chose, that means I need 1 more day. So num day we will increment by num day, or I should rather name is num days, number of days, by 1. Okay, I have to increment it, and then because I am starting another day, that means I need to reassign this as 0. Otherwise I will keep adding this weight to my current weight. So current weight will keep becoming greater by the way that my current weight, because on the same day, if this is lesser than my capacity that I'm choosing, that means I can put more weight, more w on my ship on that particular day. Okay, so I think this will return us the number of days once we come out of this loop. That means we have processed all the weights, we have collected all the number of days, and if this num days is less than or equal to days that are set for our shipment, that means that's a valid capacity. We should be able to finish all the packages within that many days. So that's our answer. So initially let's have this answer as max weights. Max weight is a valid answer, because that's at least within 1 day we are able to ship all of these. So what I'll do is I'll have res as minimum of res and this answer that we just found out, which is basically choosing m. Okay, choosing m. Okay, so by the way, this m is the capacity. You might be like, are we comparing these, and why are you assigning m as minimum? Because we have done all this crazy work here to see if that m capacity is actually valid. Okay, and you might even want to take this code out, or whatever you like, or maybe this code out from this condition, so make things easier. But I guess this is not too crazy right now. And also because this m works, but we are trying to find the minimum, so we will bring our right pointer to basically mid -1, so that we can still keep processing until this while loop becomes invalid, and that's because we are trying to minimize my capacity. Otherwise, let's say if this wasn't able to process this m wasn't able to process all of these weights within that many days, this did not satisfy, so that means we need to increment my left to mid plus 1. All right, and then I will come out of this loop, and then I will just return my answer res. So I'm gonna zoom out so that you can see the code clearly. Okay, this looks nice. Okay. All right, let's run it on the examples. Okay, what's the issue? Okay, output 10, 15, and that is because W plus current weight is greater than M. Current weight 0, incrementing if num days is less than or equals to. Yeah, I mean within that days, that's good. And minimum between res and M, minimum should be, this is fine, it should be total. Should res be total or max weight? I think it should be total. It should be total because, okay, yeah, this was my bad. Because result is what we can actually ship within 1 day. You know, that should be our upper bound, and it shouldn't be just maximum. Maximum is 10 here. In this example, it's 10, and we decided that maximum range should be basically the sum of all the values. Okay, so I think this should be good now. Yes, it is. Okay. Voila. Efficient solution. Let's, if you were to write the brute force, it wouldn't pass all the it would exceed the time limits. Okay, let's write the time complexity. Time complexity would be basically these two nested loops that you have here. So for we are processing all the weight. So let's say if the number of weight is n, that means it's gonna be big of n into what? This while loop is a binary search on this range that we decided, and let's say there were k values in that range, so it's going to be n into log k. Okay, and this is what did the trick, so that the solution is accepted. And space complexity would be constant because we're not using any space. All right, so let's go back to AlgoYogi, mark this problem solved, and see you guys later in the next problem. And remember, these problems, this one, these are kind of same. They just follow the same structure. Okay. All right, so I guess see you guys in the later videos. Until then, bye bye.